Our next group is aldehydes. Aldehydes have a chain of carbons and then a carbon with a double bonded O and then an H. The ending is Al. So if we have our Al here, we have an Al here. So let's go ahead and name this group here. Again, always easier to draw it out. So I have CH3, CH2, C, double bond O, and then an H. CH3, CH2, C, double bond O, and then the H. And that's always how it's going to add on. The O cannot be bonded onto that H because H can only have one bond. And so this O here, even though it's written at the end, is added on to this carbon because this carbon now has his 4 bonds. Well, if we look at this, we have 1, 2, 3 carbons, which are is a propyl group. So we have propanal. We need that Al. If we're going to do the opposite and we're going to draw a pentanal, we're going to go ahead and draw our 5 carbons, 2, 3, 4, 5, for pent. We'll add that double bond O and H onto the end, and then I can go ahead and fill in my hydrogens so that everyone has 4. And there we have pentanal. Now related to aldehydes are ketones. And remember, in our carboxylic acids, we had R, and then we had C, double bond O, and then an H. Well, in a ketone, this H here is going to be replaced with a different R group. So we have R, and then we have C, and then we have another group. And our ending then is ONE. So if we're going to go ahead and draw this one, because it's much easier to do for drawing, we're going to have CH3. We're going to have C, the O is right next to it, so double bond O. Then CH2, CH3. We have 4 carbons, and so we know that that's butane. So we're going to call it butanone. But now we have to specify where is this oxygen double bonded. Well, it's double bonded on the 2, the second carbon. So we're going to call it 2-butanone. Opposite, let's do propanone. The common name for propanone is acetone. But acetone doesn't give you any information on how to draw it. But just know that some of these compounds have common names. And so propanone is 3 carbons, 1, 2, 3. And we don't have to have a number with propanone because if I were to put this oxygen on the end here, it would go back to being a carboxylic acid. So in order for it to be a ketone, the only place that that oxygen can go is in the middle. I'm going to then go ahead and fill in my hydrogens, and then it's done. I'm sorry, I said that if the O was here, it would be a carboxylic acid. I misspoke. I meant it would be an aldehyde like we just learned because this is the H group. So if we had put this oxygen here, it would have been an aldehyde, not a ketone.